Hey folks, here we are with another exciting video, and this one has to do with the lab we recently finished with this red phenol solution, this mystery red color. And you might recall that what we did with this lab is that we decided to see what caused it to change color. We took a straw and we blew into it, and this is kind of what it would sound like, or something like this. Little sound effects there for you. And it was amazing. It was Halloween, and I happened to find this black cat outside, so I invited the cat in and trained the cat, gave it a few treats, and got it to take a straw and blow into the solution. And you notice it went from red to orange. Of course, that's really the whole problem that we were trying to figure out. What is it that is in your breath that causes this red solution to turn orange? And it's getting more orange as we talk here. Orange, orange. So what is in your breath? Well, one of the things could be water, could be the heat that's in your breath, and here's the actual question, which didn't come out very well, but that's okay. But it could be water. That's one. We'll test that, and we did that by taking an eyedropper and dropping about 3 or 4 more drops of water into a test tube and swirling it a bit, and lo and behold, nothing really happened. It stayed red. In some cases, it might have got more diluted, but it just stayed red. Another thing we could have checked was, well, what about in your breath in terms of temperature? That when you breathe out on a cold day outside, you see that condensation, which implies that it's warm. And your breath is 98 degrees, 98.6 degrees Fahrenheit, or 37 degrees. And we kept it in a hot water bath, that temperature, for quite a while, and nothing happened. So we could pretty much rule out the fact that heat caused the change from red to orange. And when you're blowing in there, you kind of agitated or swirled it. So I took an aquarium pump, you might recall, and we blew that through there for quite a while. In fact, it was more than 3 hours. Actually, I did it throughout the entire day, but lo and behold, nothing much happened. So we can pretty much rule out that just the physical movement of the solution didn't do anything. Next thing we decided was, might we have oxygen? Well, we got the oxygen by doing a reaction of taking this 3% hydrogen peroxide, and here we have a young researcher who was pouring some of this hydrogen peroxide into a flask. And on the label it says 3% because 97% of it is actually water, which in fact if you look at it, it looks like water. To that, of course, we added some yummy chicken liver. I went to the store and bought this cool tub of chicken liver, and ooh, that looks fun and yummy. And we then placed the two together, and when that happened, you get that kind of foaming, fizzling kind of thing, which is actually oxygen. So here is some nice big chunks of liver being placed into an Erlenmeyer flask full of hydrogen peroxide. You can see it bubbling there. The next thing that would happen is that we cap it with a test tube stopper with a hole in it and connect it to a tube, and so it allows all the oxygen to go bubbling out of there. And when you stick it in there, you'll notice it's bubbling, but nothing's happening again. So we can pretty much rule out this as a cause of the change. So in other words, oxygen didn't have a change. You notice we're only testing one variable at a time, which is key to doing any kind of controlled experiment. So what else is in your breath? Well, one of the major things that you kind of think about when you breathe out is good old carbon dioxide. Now, in order to get a pure source of carbon dioxide, we were using dry ice. So I had my son help me here, picking up, and oh my God, he picked it up with his bare hands. He's got tough fingers, but you really shouldn't do that. And you can see, I just put in a jar just to show, or he did, to show that it actually is dry ice, bubbling away. And then he places some, this time correctly with the forceps, into a test tube that has the phenol red in it. And at first nothing much is happening, but you can see there's a lot of CO2 bubbling out of there. But give it a few more seconds, you notice right now it's even starting to get a little lighter, a little lighter, a little lighter, and it's actually starting to turn orange. So from this we can probably conclude that carbon dioxide is causing the color change. Now the only problem is we also have to test for cold because we also added another variable. And as I point out in class, the real deal about this is that when you add an acid to this solution, it turns orange. That's what it's called a pH indicator. And this last shot here is actually good old Milo because he got to eat some of the liver. And boy, does he have really nice breath now. So that's most of the things we did. So hope this will help you in your write-up for the lab that is due on Friday, this coming Friday.